Okay, so good day, everyone. My name is Maciej Hruszowski with Red Hat Research, and I would like to welcome you to another part in the Research Days series. Today, we would like to introduce Petr Švenda, an associate professor and researcher at Faculty of Informatics at Masaryk University in Brno, Czech Republic. As Peter speaks, today we would like to encourage you to post questions in the chat whenever they come up. However, Petr will address them once this presentation is over. Hopefully, by the time those questions are answered, others will surface and we'll get an interesting discussion going. Having said that, I'm going to give the word to Petr and hope that you will enjoy what is coming. Over to you.
Thank you, Maciej. So welcome all here. I would like to talk about the tool we developed over the years as a need for our usages as security researchers. And it was collaborative work by many people that were involved over the time. So I really like to thank them all for the work done. And I will talk about mining of already issued common criteria certificates and FIPS 140-2 certificates. So let's take a look. So I will provide a very brief, lightweight intro in these two certification schemes. It will be brief for two main reasons. First of all, I like to spend more time on the data we are able to extract from these, so not really about the process as such. But also the second important reason is that I'm no expert in this. They likely in the audience, we do have more educated experts for this part. Then I will talk about the tool itself, which is called SecCerts, and I will show you what we are mining, what we are extracting, and how we can work with that. Then, based on what we extracted, I will talk about some insights into the whole ecosystem of certifications. And this insight will cover the period from 95 up to the last year. And then I will also talk about how this tool can be used not only to provide insight, but also to help you as ITsec guy or AppSec guy in a company which bought some certified product, and you would like to keep an eye on future vulnerabilities and how you can use our tool for that. And I will talk about the Roca case because this is something we are familiar with, and we can provide some practical examples here. And finally, fingers crossed for online demo. So I will also try to show you the web page we developed for presentation of the data collected and extracted. So let's take a look on what we are. We are in Brno, Masaryk University. Brno is here. We are a security laboratory there. And with respect to stuff that is certified by common criteria or FIPS 140-2, these are smart cards. We are involved with smart cards since 2002 when we worked for our national security authority, which was responsible for selecting and evaluating products for our government. And in 2002, we started to work with them on smart cards, on evaluation of smart cards. And smart cards and cryptographic smart cards are very pervasive nowadays. You likely have at least two of them in your pocket, in mobile phone, and as well as payment card. Yet the smart card industry is very closed, as the hardware industry tends to be. So if you would like to see more detailed specification, you need to sign NDA. If you would like to get the proprietary API, you need to sign NDA. And this is not really a good fit for us as academic research laboratory, because we at some point would like to make tools open and would like to publish the results and so on. So from the very, very beginning, we were forced to work in basically black box analysis model. So we were analyzing smart cards, but we were not getting the detailed specification. We, from the very beginning, had to write tools, observe side channels, and many other things as a black box attacker model. This is more painful than having access to, say, even source code running on the card. On the other side, from the very beginning, it put us in a situation where our tools were not under NDA, so we were able to release them, and other people can take them and also run them against their own cards in this case. And over the time, we started to find vulnerabilities. So one big vulnerability we found was a ROCA vulnerability in the way how RSA key pair was generated in large number of smart cards, and we shown that from the public key you can compute the private key, which shall not be possible at all. We also found some issues with ECC elliptic curve crypto, as it was implemented in smart cards as well as software crypto libraries, and we were also looking at the way how random number generators are used and the data, what is the quality of data coming out of it. So this is our background, and now I have a small task for you. I will talk about the tool that can mine the certificates, and based on that, it will give you some knowledge, and you can start asking queries. And example of such query is, okay, I'm interested in all tachographs that were certified after 2017. Or I'm interested in all smart cards that are referencing Java Card API version 3.0 at least. Or even which company is producing more certificates with high level security levels? Is it Infineon, NXP, some other company? So questions like this. Or is certificate X affected by vulnerability found in device with certificate Y? So all these questions, and just put them into the chat. So I will later on, when I will stop talking, I will go through them, and I will try to answer whether this is now possible already with our tool, or it's in principle possible, we just need to implement something, or it's I don't see the possibility to answer such query. So please do so, so we have some food for later discussion. And also into the chat and later with email, we have a very short questionnaire how your organization is using certified devices and how they are like connected to this field. So if you have 5 minutes, please do us a favor and fill this in, so we have some better insight what is happening. So now let's start with a very short intro about common criteria certification. So there is some vendor doing some product and making some claims, not necessarily about the whole product, but more likely about the part of the product that is called a target of evaluation, TOE. And these claims are basically what this part of the product can do with respect to security functionality, and this is called security functional components, SFRs, and what were the measures taken during the whole target of evaluation lifetime. So when it was developed, when it's maintained later on, and so on. And this is called security assurance components. And everything is written into security target document, and this document is publicly available. And these claims can be constructed based on two main principal options. First one is you will take the common criteria documentation basically as a catalog, pick up some security functional components you are interested in, security assurance components you are either interested in or required to fulfill, and then make your security target, and then with help of the laboratory you are showing that you are fulfilling these requirements. That's one option. So you have a product, there is always some part of functionality which are not certified, and then the part you are going to submit for certification, you will pick your level. In this case, it's 4, and then you are saying, okay, I'm able to offer you user authentication and anonymity and security management roles, and so on. So these are security functional components. Also, you are talking about, or you are showing what were the measures taken during the development. So you again set a bunch of these, and then you went to laboratory and showed that it's all true, and then you got certified. That's one option, and the other one. But over the time, there started to be somewhat clear that this approach is a lot of there's a lot of repetitive work for people doing basically the same thing. When we talked about tachographs, so the tachograph has some basic properties, and you just like to fulfill them. So people started to produce protection profiles, which are basically templates. So they are SRFs and SARs, and this is a template for tachograph. And then your product, if it's a tachograph, you will just show that you conform to this protection profile. And based on what the protection profile requires, you are just showing that you are compliant. So this is faster for vendor, and it's also better for customers, because they don't need to really dig deeper what you picked from the catalog of potential functionalities. They know you are compliant to how standard tachographs looks like. And this started to be popular, started in 2007 basically, but after that time you can see that these light blue are the number of certificates in given year that are conformant to some protection profile, and the dark blue are these older types. What about the level, the security level achieved? For common criteria, there are a bunch of them, starting from 1, ending with 7. Sometimes you will see something called augmented level, usually demarked as plus. And higher the level, more strict requirements what you need to show that you are doing. Basically, 1 is self-assessment, 7 means formally proven everything. And depending on the level, some certifications are mutually recognized over the whole world, up to AL2, up to AL4 inside European Union, and these claims are validated by accredited laboratories, evaluation facilities. And if successful, you will get a certificate that is publicly published, and so on. So there are some certificate authorizing members like French ANSI or German BSI here in Europe, and typically certificate goes for 3 or 6 years. If the product is still relevant after 3 or 6 years, there is a maintenance report. We just show that, okay, we are continuing further. If the product changed just a little bit, you can just make a maintenance report showing that these changes were not breaking anything. And what are the documents? And now we are getting to the part where we start to mine something. So what are the documents that are produced and publicly available here? Security target document, the document provided by the vendor describing the evaluated part. Then we have a certification report, which is issued by a certification authority member like French ANSI. And then we have a maintenance report if there was such report already issued. These are usually in publicly available as a PDF files. There are additional documents exchanged between the vendor and the laboratory, the facility, evaluation facility, which is checking the claims. But these are usually confidential, and these are not public, so we can't mine them. Then we have these protection profiles, these templates of standard functionality. These are, initially these were PDF files, but now what is interesting, a lot of them are now published as are basically collaboratively done on GitHub. So we have them in some XML file with a decent structure. So that's a good development towards the automatization of processing. And then we have a bunch of other informations that can be obtained from various sites like Common Criteria portal or FIPS 140-2 portal on behalf of NIST. And these are either CSV files or HTML pages and a bunch of things you can just download and start to search for something useful inside. So NIST FIPS 140-2, it's quite similar to Common Criteria, but there are some big differences. First of all, it's more specific. With Common Criteria, you can certify basically everything, while the FIPS 140-2 is focused on cryptographic modules, so stuff that really handle cryptographic keys and execute cryptographic operations. And the product the part you are certifying is called a module and has some number, usually something like this. And then there is also something called algorithm, which is the specific implementation of security algorithm by this given module. Again, assign some number, and there is some mapping between the module and the algorithms implemented inside that module. So think about AES implementation or key wrapping via RSA algorithm and stuff like that. Public documents here, security policy document, which is similar to security target from Common Criteria. You have also certificate web page, and you can start download these parts as well. Okay, so there are some data, we can start mining them. So how to do so? There are some problems. So first of all, we can't just get all the data, and we can't get them quickly because it takes quite a long time for certification to be even performed. So these documents are not short, and the overall certification is quite costly and takes a long time. The figures I was able to find was something north of $100K, definitely more than 3 months, and so on. This works well for static, long-time usable products like smart cards, like the integrated circuits inside the cryptographic smart cards. Like this can run for years with no change, but it's definitely not suitable for something that quickly change. Imagine that you have some software deployed in cloud with daily updates, and like this is clearly not compatible. Another thing is it's quite hard for end users to interpret the security, the claims that are made. The evaluation itself is not done to the whole product. It's done only to usually sub-part of it, the target of evaluation. And depending whether the vendor is doing the whole target evaluation himself or herself, or it's according to protection profile, some crucial parts can be put out of scope of the certification. So you might see some claims like Common Criteria certified, but this doesn't mean anything unless you know what is the part of target of evaluation. Or Common Criteria ready, which means it's not even certified, it just can be eventually go through put through the certification. So imagine that you have a product like this where most of the functionality is not certified and out of scope, and only some small subpart is certified, maybe to level 4. So that's clearly a bit misleading. Also, the products are changing, so what was certified is not really what is certified at the moment. And another important part is how well the product is scrutinized by testing laboratory. And there is a lot of trust at the moment. You need just to trust as end user that laboratory did a good job, that they checked everything, that they used state-of-the-art tools and the knowledge. And exact procedures are under non-disclosure agreements, and also intellectual property of these labs and vendors and so on. So a lot of things are just hidden from the end user and or us as academic researchers. So what are these portals I was talking about? There is a Common Criteria portal on this page, and these FIPS 140-2 certificates are on cryptographic module validation program. So you can just go there, start searching for certificates. A lot of interesting data there. So some random examples of how actual certificate and security target look like. So if you will pick some, this is completely random example, no vulnerability in this one found by us. You can find interesting things there. First of all, certificate number, some unique identification, what is that uniquely identified this particular certificate. You can also find the security level. So in this case, EL5 augmented because there are some additional security assurance components taken from higher levels. So it's something above level 5. You also see that this is conforming to particular protection profile, in this case, some Java card protection profile. You also see the testing laboratory who did the checking between the claims and the reality. And if you will dig deeper, you can also find interesting other things like references to other certificates. So within this one, other certificates are reference. So that's interesting because you can, of course, if there is a vulnerability in something your certificate is using, potentially you are vulnerable as well. You can also see versions of cryptographic libraries used there, versions of integrated circuits, API versions, a lot of interesting information inside. What you can do with this? It's PDF file, so you can extract the text and then make a word cloud, which is nice, but we can do better, definitely. So let's try to do better. So imagine that you have a crystal ball where you can ask any query regarding the certified products. And so what are the questions you would like to learn answers to? Put them into chat, please. But I have some answers already that we had. So first of all, we would like to be able to browse certificates in more readable form with the properties extracted based on what we would like to see quickly, not really what someone else decided it's worth of publishing and showing. That's one thing. Second thing is, there are a lot of certificates at the moment, like 4,500 plus for common criteria. And this is a lot of text to read. And based on that, we can get some nice insight into the whole ecosystem. What are the trends? What security? What are the trends with respect to security levels? And so on. So I will show you some examples later. Also, if you will see in the news some notice that there is some vulnerability in product X, can you quickly verify that whether this is relevant to you or not? That's quite important question you would like to quickly answer, not just wait for vendor to tell you that you are vulnerable or not. Also, if you would like to be a proactive and you know that you have your particular device bought, there is some particular certificate, maybe you can proactively look for other certificates for signs of issues. So, but what are these other certificates? You can also think about your own analysis if you have the raw data, and right now you have basically a bunch of PDF files. So what we are trying to do and what we can already provide is basically JSON file with extracted raw data, and you can start doing your analysis on top of this. Any additional idea, please put them into chat. So let's talk about the tool itself, how it's structured. For the common criteria, we are accessing these more than 4,500 products, plus security targets for these products, plus maintenance updates. So there are quite a lot of files available. We are also scraping the web and database, which is provided in CSV format. then we are looking for various parts inside these PDF files. There are front page, which contain obviously some interesting information. We can search for interesting keywords, basically by a bunch of regexes. And we can also look at the metadata stored in the PDF files. What you will quickly learn is that these PDF files and these target of security documents about the products are written for humans, not really for a machine processing. So basically someone just took the Word editor and starts typing stuff inside, depending who is that, different templates, a lot of typos and so on. So it's not intended for automatic processing, it's more intended for human readers. And for that it works well, but we like to do automatic processing. Another source of interesting data are these protection profiles. These are, once again, as a PDF files or also XML files in some cases. So this is getting in a good direction, but most of them are just PDF files. Based on this processing, you will first extract some raw data. We are putting them into JSON format. Then we need to pair various files together. The files that are relevant to one particular product, we are pairing them together. Then we need to clean stuff and normalize it somehow, because as I told you, there are a lot of typos and not always the same exact string matching the name of the device and so on. So this is now available, and based on this you can start doing some analysis. So you can start doing visualizations. I will show you some. And also you can run your custom analysis. This is work for you if you will become interested in this. So just the JSON, don't expect anything stellar. You just have the subsections that are telling you from the front page scan, we extracted this certificate ID, and the laboratory was, say, BSI, okay, and stuff like that. Large JSONs, 130 megabytes, but you can quickly work with this. What is interesting is out of all active products and certificates for active products, not all of them can be downloaded. There are broken links, invalid PDFs, some are encrypted and stuff like that. So it's most of them are somewhat okay, but some of them can't be reached. And in total, more than 10,000 documents. So let's take a look at some data we can extract this. So some ecosystem insight. So first, natural question is, what are the number of devices certified over the years, and what are the categories of these devices? So what is certified? Count criteria has these basic types of certified devices, and based on the processing, you can start drawing graphs. So what you see here is everything ending in 2020. We just cut the data set here for the display, and it started somewhere here. And you can see the first observation is more products than ever were certified in 2020. So the certification is just getting bigger and bigger. Second thing you can see is that the popular categories are smart card, cryptographic smart cards, and integrated circuits for this domain, and so on. Also, network-related things like firewalls, multifunction devices. These are printers, copiers, and stuff like that. There are other devices that can't fit into any of the outlined categories, and because we are talking here at Red Hat Research, operating systems are not that huge part of the overall certified devices. This makes sense because operating systems tend to be big, so it's harder to certify them than something that is small. That's one thing. Second thing is we don't really need thousands and thousands of different operating systems. So this is just a different way how to visualize the same data. And here you see clearly that the smart cards are the most commonly certified items. Other devices and network related are below that. Operating systems are somewhere here with the rest. So this is one type of insight you can get. Another type, another question you might ask is, who is issuing these certificates? So who are these certificate authorizing members? And again, you can see that the most active right now is France, and basically was most of the time. United States are fluctuating, but are still very important. Germany, some fluctuation, but significant as well. Canada is here as well. What is kind of surprise, and it was, at least was for me, as the Netherlands, which was somewhat small, these are the number of certificates issued per year. Okay, so it was something like 10 certificates per year, but in 2020 it was like 50 plus. So it quickly goes up, and it's now the third most productive certification authorizing member. Then another question is, who is doing these devices? As you might expect, this is mess because there are so many different vendors. So it does not really make sense to plot the graph with all of them. This is just 20 top manufacturers, and still is a mess. So here to get some reasonable information, you need to focus on your domain. So to pick, say, smart cards, and then look who is major vendor there. It's not that easy to figure out who is the major manufacturer or vendor here. There is some heuristics, and this is just one out of many heuristic steps we had to perform during the mining. Because, for example, you can find all these 4 types of vendor strings in certificates. And they all mean the same company, same manufacturer, or same vendor. But because of different, let's say, divisions of that company and so on, they have slightly different names. And either you will keep it separate and you will have somewhat skewed results, or you can try to apply some heuristics and figure out, okay, let's call all these 3 the same title and have it as a single vendor. For the smart card world, the most popular manufacturers are these 4, and they are also the most popular overall because most of the devices that are certified are smart card and integrated circuits. So these 4 do have a consistently large number of products certified over the years, and there are some trends, like someone spiked in 2016 Obscure, and then it went down, and then it was renamed under the IDEMIA title, and then the IDEMIA is now spiking. So you can start to see trends here once you will focus and limit on some smaller domain. And that's quite easy to do when you have the raw data. Another question is for how long the certificates are valid. The 6 years, so you will just plot the histogram and figure out for how long the active certificates are here, and also the archived one for how long they were here. 6 years seems to be a default, but there is some variation here. 3 years are popular as well, seems to be another default. Maximum we observed was 21 years, which is quite a lot for 6 certificates. From the security point of view, it's interesting to look at the certificates that have unusually short time of being valid. And we found 6 certificates that were valid for 1 year or less. In some cases, just 1 month. Some of them you can even guess why this was the case. So, for example, for Samsung Galaxy Note 7, this is the famous phone with burning batteries, like this is some VPN software running on this, but likely it was archived together with the whole Samsung Note 7. When are certificates archived? So we talked that there is 6 year and 3 year and so on, but there was one interesting outlier we saw. And while going through the archive dates, suddenly we saw that in 2019, specifically in September 2019, there was a huge spike of archived certificates. And we thought, why this is the case? So let's take a look and start analyzing the certificates that were archived at that particular moment. And again, it's very, very easy when you have the raw data and you can start looking at this. Otherwise, the archival rate is somewhat stable. So basically, all you need to do is just say the condition. The condition is written here in Python. If you know the Python, then it's easy for you to read it. And basically, you will say if the archival date is 1st of September 2019, then just filter the certificates and then just plot all the data, all the graphs, all the figures as before. So it's really easy to do. Just filter the certificates and then look what is there. And basically, you saw that it was mostly the older certificates from smart card and smart card related devices, large number of different vendors, mostly from Germany, France, Norway, and Spain. And almost exclusively, these were the certificates which were 6 or more years old. So initially we thought, okay, maybe something really terrible happened, but it was likely just some cleaning event. But for us, it was important that we can quickly test such event and figure out whether there is something suspicious or not. And you can do the same for your particular scenario as well. Good. Let's take a look at security level certificates, because not all devices are equal. Some they are with even a formal proof of behavior, while others are just, okay, we did a good work and we followed some best practices, but we don't really need to show anyone compliance and so on. So these EL levels, we have EL levels from 1 up to 7. This plus means augmented, which means it's 1 plus something from the higher. And also I put here 0 plus, which basically means it's not even EL1, but it has some components from EL1 or higher. And what you can quickly see out of this is we have more and more secure certificates, or at least with respect to security level. So EL5 plus is here, EL4 plus is here, 6 plus is also on the rise, which is already quite high level. And a lot of them are, especially since 2012, are according to protection profile. So instead of directly saying we are level 4, they are saying this is according to protection profile, and then you will figure out what the protection level is based on that protection profile. Highest internationally recognized level, EL4 plus, peaked in 2012 and now is basically stable. 5 and 6 plus are gradually increasing. So overall, it seems that the products are more and more secure. One surprise for me was there is something even EL7 plus, which basically means 7 is formally proven and verified, and plus is something even more. Not many of them, but there are such. Protection profiles are getting increasingly popular, as you can see here. Then you may start ask, okay, this is for the whole ecosystem, all certificates together. But what if we will start to separate them? Are there any differences between the domains? Let's take a look at smart cards. So for smart cards, 4+, 5+, 6+ are the most popular. You can see them here. So what about the operating systems? You can see that most of them are 4+, but tend to be also lower. And also notice the number of certificates per given level. Here 80 and here 600, so it's order of magnitude different number. So very few certificates for the operating system category, and they tend to be lower level than for smart card. Makes sense, different types of devices. Again, you can do this for your domain. These security assurance components. So basically how good the manufacturers were during the development, design, and also maintaining during the whole lifetime of the product. We can just search these certificates, extract these SARs, and just again draw a histogram to see how many of them which are the most popular, which are infrequent. So these are the frequent ones. No real surprise. If you like to do something, you need to have functional specification. You like to have also independent testing and development security. This makes sense. Sometimes you will see point something. This is basically the level within that particular component. Higher the better, obviously. So here these are the whole classes, while this one is already one specific subpart. We will take a look on this in the next slide again. And there are also some infrequent classes that are almost or components that are almost never used. So for example, vulnerability analysis to very high level, it's seldomly used. You can start drawing heat maps, which basically means you have these components extracted, these security assurance components, and you can start to look if someone picked development security. Are they going more for development security level 1, which is the basic one, or they will go for level 2? How many certificates with that? So darker the color, more certificates achieve particle level. We have 7 levels with these components, and these are all values. There are a lot of them, so it doesn't really make sense to try to read them at the moment. But I just highlighted some for you. So for example, people are doing development security up to the level 2 usually, or they are doing level 2 usually. Some of them are doing level 1, but most of them will go for level 2. While say for functional specification, the variance is way broader. Someone will take a very rigorous approach, high level. Someone will just make a informal functional specification. You can take a look at your favorite company, limit the data set on your favorite company, and then take a look how they are doing and compare it maybe with other company. Mostly so far, I was talking about common criteria ecosystem. So let's take a look at something from FIPS ecosystem. The great stuff you now see are from common criteria results, and I kept it there to give you the comparison between the FIPS stuff and common criteria. So what about the number of certificates and categories of certificates? So the number of certificates overall in FIPS 140-2 ecosystem, it's somewhat smaller, not too much, but somewhat smaller. It peaked here. Now it's decreasing. I don't know the real reason, whether this is just a fluke and it will go up again, or there is some clear trend. There are different levels of security. Basically, it's more focused on security cryptographic modules, and the levels are how good the module is protected from, say, physical attacker. So if you are level 1, you don't really assume any physical attacker and no specific physical security mechanisms are required. If you are level 2, you need to provide some evidence of tampering. Level 3, you need to be able to detect that someone is trying to get into your device and being able to somehow respond on that. And the level 4, the highest one, the attempt to penetrate your device physically has a very high probability of immediate keys deletion. And once again, they have these augmented classes, which basically means it's 1 plus something from the high level. Not everything, but something from the high level. Okay, so this is for the overall number and levels. With respect to validity time, the FIPS certificates are more consistent. They are typically 6 years, and then it's archived. So they are more common. There are some exceptions, of course, on both sides, but way less than for common criteria. And now let's stop about the insight into ecosystem, and let's talk how you can use the tool to analyze some event that happened. Some vulnerability was published. There are some news articles about this, and you like to figure out whether you are affected or not. So we will use a ROCA case, which was a vulnerable RSA key generation in Infineon library on Infineon chips. And basically, based on the public key, you were able to, after spending several thousand of euros, you were able to extract the private key. And that's something that shall not be possible, but for 2K RSA it was possible. And it was not just some smart cards. At the end, it was concluded that the vulnerability was in 1 to 2 billion of chips. And these chips were used for various purposes. Electronic identity cards and various e-health cards, that was one. Then it turned out that it's used inside the trusted platform modules, and the BitLocker is storing keys inside that for decryption of hard drives. So there was another issue. People were using this to do software code signing, authentication, PGP, encryption, and so on. So various domains were impacted. So let's take a look how we can figure out what is impacted here. In news article, you heard about the vulnerability, and there is a CVE. Okay, so you can go into CVE database and you can take a look. But then you are somewhat likely surprised because it talks mainly about the trusted platform modules, not really about electronic identity cards, not really about code signing. There are some keywords you can start to work on. The acronym for vulnerability, but that's not that helpful. RSA lib, that's possibly interesting, and so on. So you can start looking. Naive idea would be, let's search the Common Criteria portal, the portal offered by Common Criteria members, for RSA lib keyword, but you will get just 3 hits. Okay, so that was not really convincing. Or the problem is small. Okay, that's another option. If you can dig deeper and you can figure out that this is the version of library that seems to be vulnerable, you can get more results. You can get 46 hits. You will get the PDF files, but you need to download them and then search through them and investigate. Seems to be a lot of work. Definitely not a quick result. And there are other problems. Is the library for that particular version only vulnerable, or others are vulnerable as well? is my device even using this vulnerable chip? Which are the vulnerable chips with these libraries? And so on. And after some digging, you will figure out that there are 100 plus certificates for potentially vulnerable chips, and maybe you don't even know which is inside your IoT device. So a lot of questions. So let's take a look how we can answer them. So this was one part we had from the view of vulnerability researcher. We had just one Infineon card at that time, and then we were searching who else is impacted, with whom to responsibly notify, and so on. And then there was another interesting case. There was something called IDAS incident report in January 20th of 2017, and where roughly 1,000 Austria eHealth card certificates were revoked. And because the IDAS regulation requires, in case of some security issue, to notify other IDAS members, which basically means all European countries, there was a report about it, and this report was circulated. But there was the report was not specific enough, really. It was a third-party failure, but concrete vendor was named, but it was not the vendor doing the vulnerable chips. And as a result, Estonia missed the relevance to their Estonian IDs and realized this only several months later on, just before the election. And so then it was a bit stressed situation. In ideal world, these pictures are generated from the common criteria certificates, but they were selected so they are like nice ones, right? The easy to see, not overly complex. So in ideal world, if you will figure out that this particular certificate is vulnerable, and you know these connections, so this certificate uses this one as a subpart. Maybe it's chip inside the bigger device, something like that. So then you will just like take a look at all either direct or indirect references and assess whether they are vulnerable or not. That's ideal world. But there are some issues. First of all, the graph is usually more complex. So this is another snippet out of the whole huge graph we are able to generate at the moment. So it's more complex. That's one thing. Second thing is these references are inconsistent. So we are just mining the PDF files, trying to find some references to other known certificate IDs, and then just build the graph based on that. If they are not referencing ID, or if they have a typo there, of course we will not have the complete graph. Another thing is such graph is not provided by common criteria at all. Same is the situation with the FIPS. So we don't have even such graph. Now we have it, but before it was not possible. So how the certificates are cross-referenced and what is the complexity? Basically, this particular NXP chip is the chip which whose certificates is most directly referenced 35 times. But if you will also take the indirect references, you will see that almost 100 times this particular Infineon chip. And as a coincidence, this chip is with the library, which is the Roca library, the library that was vulnerable by Roca attack. So this is somehow showing that the reason why the vulnerability overall was with a high impact was because these certificates, these smart cards, were very widely used. So you can just take this one particular chip and plot the the graph showing the references. So these, what you can see here, are all direct or indirect references ending up with one vulnerable certificate. But the issue here is the vulnerability was not in one specific integrated circuit. The vulnerability was in a cryptographic library, which was in more than 100 other smart cards from the same manufacturer. So actually, this is just showing graph for one vulnerable chip, but we have 100 more of them. If you have such kind of graphs, maybe the good idea would be, and we can start thinking about this right now, identify the certificates that seems to be critical ones, in a sense that a lot of other devices and other certificates are referencing these certificates, and maybe put some additional scrutiny to them, because if they have an issue, large number of other devices are impacted. Just to give you the feeling, what is the level of references between the common criteria certificates and the FIPS certificates, common criteria reference graph is way more dense. Okay, so what you can see here, there are big clusters. Some certificates are not referencing anything else, but these common criteria tend to have more complex references, while for FIPS, most of them nothing, and just some small pockets of referencing, but way sparse. Another way how you can use the tool we are developing. So there was this Austria with 1,000 certificates revoked, very small one. These were e-health cards, but Estonia was really hit by they had 700,000 of certificates revoked based on half of the population, basically, and so on. So how this happened, and was it possible for Estonia to get out of the Austria incident report some more warning, especially if they would have the tool at that time? So this is the snippet from that incident report. It's saying it was in 2017, the severity was high, it was third-party failure, it was circulated on 20th of June of 2017, and now, interesting part, these are the platforms that were vulnerable for Austria e-health cards. So you have something to search for. If you will just search the common criteria, you will quickly realize, okay, I have the certificate IDs for these two, which is nice. I can start dig deeper. There are also other interesting information, like weaknesses in asymmetric crypto library, and even creation electronic signatures by means of either RSA or ECDSA is okay. This is not an issue, like no evidence of weakness in here. And based on that, you can start reasoning, okay, maybe it's in a key generation. But in hindsight, everything is easier than when you are when you have this certificate for the first time. But okay, we have two certificates that were flagged by this Austria report. So can we start building graphs based on that? And by using our tool, you can use do find affected keyword or switch, command line switch, and then you will just put these two into searching, and you will get graph like this, which is very, very small, like very surprisingly small. These are two certificates that were vulnerable. Okay, so these are what we started to search for. And the whole graph looks just like this. Nobody else is using these certificates, so there is no connection from top. And these certificates are referencing only two other certificates. Okay, these two are not certificates; these are a list of certificates published at some point. We need still to clean the data a little bit. And if you will open these two certificates, you will get some additional data. You can see here that they are basically the same controller, only with some minor variance. They do both have same version of library, though, for the crypto. And this is the vulnerable one. Okay, but the Austria report was flagging something that was quite new, not really used by other certificates. So at the end, it was quite limited. So just based on the report and just looking at what were the certification IDs, it's quite hard to get other certificates that were impacted. Even if you will take these two Infineon certificates, these two that were these two, okay, and start searching for the certificates that are referencing these two Infineon certificates, then you will get a quite complex graph. These are these two seed certificates we started with, and you can see that all these certificates are either directly or indirectly referencing them, in total 127, but Estonia certificate is not among them. So what they had is this particular certificate ID, and this one is not within these 127. Okay, but we already know that we don't have just one vulnerability. We have a lot of them with the same library. So can we like search more about this? So we can start to build the set of initial certificate IDs that we will later populate to see the whole graph from a target keyword. In this case, let's start with the keyword, the version of the cryptographic library. And for this, again, our tool has some support. So we will just specify that keyword and let it run. We will first get all the certificates which are mentioning this keyword, and then we will start finding the certificates affected by these seed certificates. And in total, we have 282 certificates, and Estonia is directly included among them. And they even mention directly the RSA library in their certificate. So would it be the case that the Austria report was mentioning the directly this version of library? It would be easy. At that time, it was not yet publicly disclosed, so it was the certificate was the report was telling you something, but not really enough information. So this is what you were able to get out of these two certificates from the Austria report. This is the great part. These are the certificates you are able to get when seeding the search from the keyword of the version of the cryptographic library, and Estonia is somewhere here. Okay, so more information you can feed in, better for the tool forward. So let's prepare for the future vulnerabilities. There are questions like, okay, I have a device, there is a certificate X for this, which other certificates to actively monitor? Let's take some example. Quick one, no vulnerability, this is just a random example. Once you have the certificate ID, you can just use another switch from our tool, and then now you are asking which certificates either directly or indirectly referenced by my device. Okay, and this is my device now, and all these certificates can eventually lead to the vulnerability in this one. Okay. Not for sure, of course, it depends how it's used, but I need to keep an eye on these certificates. And you can then look what are the manufacturers of the devices I'm dependent on, what are the levels I'm dependent on. If I have something that is really high level and I'm depending on something which is really low level, okay, that's likely an issue. So maybe we have some disbalance between what we are dependent on. Now I will try to quickly show you the demo, and then we will almost end. Good, so I will try to switch sharing. So I hope you can see the nice effect, right? And then you can see my web page. So, or not my web page, the web page we developed, and I would like to show you something about. So over the time, we are extracting the data and not only providing the JSONs, but we are trying to provide also some visualization. So for example, for common criteria, you can go and see the whole graph. You can zoom in, zoom out to see what are the important components. You can take a look, and if you are interested in particular certificate, you can just jump to this. So far, we extracted some information out of the certificates, which is shown here. You can take a look, for example, what crypto algorithms they are using, and information about the device, what are the security assurance requirements found in this certificate, and so on. So stuff like that. And also, once again, the smaller. So you can see that, for example, for this certificate, the number of directly or indirectly referencing devices is quite a lot, right? We have 500. So I picked just randomly, basically, but I picked something that is significant. Okay. So let's zoom a little bit out, and you can go and search for stuff, obviously, no surprise here. And over the time, we will start putting the analysis here. At the moment, there is only very few items here. Same for FIPS certificates, same issue. And now I will move towards the last few slides. Good, let's do it. So what are the steps, how to improve the certification transparency at the moment? So we started with the first step. We took what is available and tried to extract the raw data and make better interpretation based on what is now available. And already it's quite usable, at least what we feel, and was usable in past for us. Then another step, future one, is to generally provide more information about the device certification process. Over the time, there were multiple vulnerabilities. We found some of them, but just few, but many others were found. And despite the fact that everything was certified frequently to high levels and so on. And if you are then searching why it happened and how the laboratory shall improve their evaluation process, you can't even find how they were doing the stuff, what kind of tools they were using, what were the settings of these tools, what are the results obtained, and so on. And from the perspective of end user, I'm not really happy with a situation like this. I would like to ideally repeat the certification, the testing process myself to see that what I'm getting is still okay, still passing, and I can make my own conclusions based on that. For this, we need some freely available tooling, because it's no good if it was tested, but something that costs $10 million, then okay, ordinary end user can't really get it. I'm not saying that you can do this for all types of analysis. Of course, some stuff is expensive and can't be get for free, but we can do this, I believe, for a lot of parts during the certification and the evaluation. Ideally, something like continuous certification, that for people that are doing the software development are familiar with the term of continuous integration, where the product basically all the time integrates together every night, everything is compiled, tests are run, and if we broke something, we will quickly learn that. So ideally, we would like to have something same for certification as well. Then we shall more anticipate future vulnerabilities and prepare for that. When we were notifying about the ROCA vulnerability, we also wanted to open the CVE. And the response from the vendor, otherwise Infin handled, I like to say this loud and clear, they handled everything very professionally. It was, I think, no threats. We were a bit afraid initially, but no threats at all, and everything was fine. But they said, in our industry, it's not common to fill CVEs. So then it's way harder to find to have the exact identification of the vulnerability and then propagate this information. So ideally, just prepare for the fact that there will be vulnerabilities. We would like to be able to track them properly. So we first need to know if we have products like this and there are components of this product, to have a clear identification of these subcomponents. And if there is vulnerability in one of these, we immediately know which other devices are potentially vulnerable. That's one thing. Second thing is the clear entries for vulnerability. There is the CVE database has the common platform enumeration, which identifies vendor, software, or type of product, and including the version. And if you will prepare the items like this, then it's way easier for people to assign the vulnerability to correct reference, and then it's easier to track it. Also, some data are public, but it's clear that from the certification process, more data are also available. And I'm not talking about the confidential documents, which, okay, would be great if they are not confidential, but okay, there is a lot of IP and so on. But I'm talking about, for example, the data from which the Cafeteria portal is generating their web pages. They clearly do have additional information here, but we can't get that directly. We need to just get what is available. And maybe this database can be also made public. And if the overall aim is not to provide something that is intended to be read by a human, but instead intended to be read by a computer, which can then do the analysis, that would make the whole process efficiently computable, and automatization can be built on top of that. So if you know the continuous integration from software development, you basically have a software, you are pushing it somewhere to some source control like GitHub. Every time you will push something, there is a webhook. Continuous integration service will pick it, run tests, and either test will fail, and then you know that you broke something, or they are okay. You have the clear versions of everything. Everything is like recorded. You can rerun it again. Hopefully, it's deterministic, and you will, as a result, you will get some binary artifacts. But you have also logs about the whole process. I understand that for certification of physical devices, especially, this is more difficult, of course, because you can't put into source code, source control the whole smart card. Yeah, it's a physical device, but at least you can put some firmware, everything that is running inside. You can put there. You can run tests as before, but there are issues, of course. Artifacts are no longer just software binaries, but also are all these parts like firmware, masks, and various settings using for tests and power traces maybe you did during the testing and so on. Also, the test itself, to execute, might be elaborate physical setup. Various specifically configured devices can run for a long time. That's another thing, with manual expert steps and so on. Also, the test may fail not only because something is wrong, but just because we do have some non-deterministic behavior of tested devices. For example, random number generation. The random numbers sometimes don't pass tests, and it's not that they are bad, but because we are unlucky, we just hit something that looks like a non-random, but it's actually still random, but the tests were rejected. So it's not easy, but if we can start putting more and more open tools here, at least some parts we can repeat and automate. Another idea here is if you are familiar with GitHub development, they have Dependabot, which is an automated bot which is looking for files that are specifying what versions of software you are using, modules you are using. And GitHub on their side, and GitLab is doing the same, and others as well, they are searching for vulnerabilities in different, or they are monitoring vulnerabilities in different modules. And if they will figure out that you are using JUnit in this version, and they have information that this version is vulnerable, you will get the notification. That's one thing. And they can even automatically provide you with a patch for this vulnerability. In this case, they will just increase the version. Okay. And so can we have something like search Dependabot? That would be nice. So finally, take home. Certificates itself contain trove of interesting data, which you can get even without NDA, which is really nice. Cert tool is released as an open source. Okay, I just have it hidden, but on the previous slides you were seeing this link all the time. You can use it locally. You will just run it. It will download stuff, process it, and so on. Ecosystem inside is possible. We already have a bunch of different ideas or insights graphs how the situation looks like. You can use it for vulnerable analysis, both from the point of pen tester as an attacker as well as defender. Basic issue right now is certificates are written for humans, not really for automatization. So for the future steps, let's try to do better on this front. As a tools, as a byproduct of our research over the years, we released a large number of different tools. They are, of course, not solving whole issues for all different types of devices, but for the domains we were interested in, we produced a large number of tools that can be used in this open source tooling world. And that's all from my side at the moment. Let's take a look at questions. So I will switch into the main room and take a look how it looks like. So I see that there are a bunch of questions here. So I will basically maybe ask Matěj to pick questions that are there, and let's take a look whether our tool can try to help with these scenarios or queries.
So firstly, thank you for a compelling presentation. In the meantime, I managed to put all the questions together in the document.
Perfect. So I will stop sharing, right?
I tried posting them in the chat, but it completely destroys the text, so it would look garbled. So I'm just going to read them for you. Question number 1 is from Dan Königsberg, and I believe that's a suggestion for a query. Which products of company are certified?
So what we can do right now is you will specify the company, the string identifying the company, and we can just give you the list of all products that are there with that company as a vendor. So that's easy to do. That's possible. Thank you for this. And but okay, we don't have it so that you can just run this from the command line. So this is nice suggestion to add to the command line. If you will make your hands a little bit dirty with the Python code, that's really easy to do. So this is doable. Nice thing. SRF, yes, that's it. Security functional components, SFRs. That's correct. Thank you for this. For FIPS, how many FIPS certificates use or point to OpenSSL certificate? Yes, that's easy to do. Basically, you need to figure out what are the certification IDs assigned to OpenSSL. Might be more of them. And then you will just run the search and we will give you the subgraph. Direct, preferences, and indirect. That's already supported with these find affecting and find affected certificates. Yeah, it's more expensive. Joshua said that at least a year and 250K. Thank you for this. How many currently certified products have vulnerability? That's to answer this particular query. What we need to be able to do is first have a good mapping between the certificate and some string identifying the certificate inside some vulnerability database. So the vulnerability must be public, must be in vulnerability database like CVE, and we need to have the mapping here, which, for example, for Roca vulnerability is not really the case. Inside the CVE for Roca, there is not an ID of particular certificate that is vulnerable, but there are a lot of them. So that's more difficult to do, but like for computers, it doesn't really matter that there are 100 items or records. Vulnerability or known vulnerability. Okay, so Brandon commented, yeah. So my guess is all of them have vulnerability. Some of them are not exploitable, and some of them will be never recovered. But that's the situation. I would like to know what the lead time is between new hardware generation and when the certificates using them start to appear. Okay, that's really interesting. For this, what we need to add is some additional oracle, which is able to tell us there is a new hardware, which is not yet certified, but it's already somehow public and we have the time. Then there will be time when the certificate is for this particular hardware available. And then after some time, we will start to see the other certificates referencing this original one. And it's likely easy to do, basically recurrent run of give me certificates that are referencing this particular certificate. And if you will find some diff, there is some new certificates, send me email. That's possible. Nice suggestion. Yeah, depends on the vendor. Some certify in parallel with development. Okay, so you already started to answer these questions, and thank you very much for that, Gerrit, because you likely know this better than I do. Is the increase in certification being driven by purchasing requirements for certification, for example, by government agencies? I think the compliance is a big role. So people are not doing the certification because they love the process and they think that their product will be even more secure after doing the certification. Actually, I initially thought this is the case, that people would like to get a good feedback and improve their product. But then people were laughing at me and said, okay, it's mostly compliance. But there are people that can comment on this more. I believe it's just by requiring people to follow the good development process and procedures, this is somehow increasing the level of security. And also if you are a certified device and you will find some vulnerability, you must report this vulnerability, and so also the level of flow of information might be better than without it altogether. Interesting that there is so much fluctuation and peaks don't match. You likely mean that the list likely meant that the peaks between the common criteria and FIPS certificates. Yes, I was also surprised. But I think what was visible there were things like there was 2008 crisis, and like companies had other issues to do than just paying a large amount of money for certification. So that was also a possible reason for some fluctuations that are there. In the US, there are more restrictions on customers getting waivers. We need vendors to react with additional certifications. Yeah, so the compliance and requirements. Thank you, Mark. 21 years valid certificate. Yes, that was, and there were, I think, 6 of them. So I can, I don't know right now the names, but I can give you. Some of them were archived during that big archiving event in 2019 in September. How do you handle company purchases, mergers in your data clean? Yes, okay, so that's a really good question. I shown you some merging, how we for BEA systems, how we did the merger. But we are not really building the knowledge database, knowing that Overture was then bought by Idemia or renamed, and this is basically still the same company. We are not doing this. What we are doing is we are basically searching for some same substring at the beginning of the name of the vendor. And that worked well as long as you will leave it at least, say, 4 or 5 characters, then this heuristic works well. But for a lot of heuristics, you need to just run it, see what are the results, and then filter as like expert view, a human view, filter out what is nonsense, and then you can do better. One improvement here might be that together with the data that are extracted directly from the certificates, we might also build some file containing mapping. Basically, all these names of vendors are the same vendor, and let's report it as BEE, something like that. This was 5 years after the CCRR was signed. Yes. What was interesting was these agreements. These are also changing. So, for example, UK, it was visible that UK was less and less being the country signing and providing the certificates, and at some point they dropped out of the group. So you can even like somehow predict the future based on the level of inactivity. But likely for insiders, this was also already clear. But for the people outside, we were looking at the certificates only. Okay. Jarda Řezník is asking, expect less higher EL for, and Joshua comment that EL does not equal more security. Yes, understood. It basically means more thorough level of how the parts are tested, but they can be still insecure. The library where we found the Roca vulnerability was tested properly to high levels, and also there is some, like from my side, for the security negative feedback loop, in a sense that if you have something certified, you don't really like to touch it, because it costs you a lot of money and to recertify. So even if you know that something is not really state of the art, unless you have good reasons to change it and then go for recertification, you are not touching it. So this tends to keep the old things in place. So the Roca vulnerability was introduced maybe even as early as 2004 or something like that. So it was here for a long time, and that contributed to a number of devices impacted. In the US, NIAP, there is no EL, just pass-fail. Yeah, okay. And that's another interesting thing, because we have the devices that are under US or they are under the European style of common criteria, so there are differences. We haven't really looked at this part yet. How many SFRs on average are included in protection profile compliant with EL4? Good question. You can answer this, and you can even answer this over the time. So some things you can either take all the data set together, or you can see how this is changing over the time. Nice suggestion. We will take a look on this one. Great. This would be a great talk. IICCC. Okay, should submit extract. Okay, we will take a look. Consider this. Okay, so that's for Ashit. Great. So Ashit will submit the slide deck. That's nice. And okay. I think we are at the end. I just like to highlight that the tool is public, so you can just go to GitHub and first of all you can take it and run it for yourself, and of course you can help us to improve it. The contributions are welcome. We have the first version of the tool. And guys are working on refactoring of some parts to make the analysis easier and faster. But this is something for us that is not just for the next 2 months. We like to be in this field for longer and try to help longer. Good. So that's all from my side. Matej, do you have something to add?
We have about 20 minutes left, so if anybody else has any other questions, you are welcome to ask them now. Also, there's a button to the top right saying share audio and video. If you'd like to come into the room with us and talk face to face, you are also welcome to do so. We'll give it about a couple minutes, and maybe there's about 20 minutes for discussion, if anybody likes. Also, Petr, you might have already said this, but will you be able to share the slides with everybody?
Yep.
So we will send them in an email later.
Will be the chat preserved, or shall I somehow?
I have already done.
Okay, so you copied because there are some good suggestions. I like to investigate deeper and hopefully provide the functionality for this.
I have copied everything into the document for you.
Thank you very much. I'm looking again into the questions. But I really like the suggestions. We need more data inputs here. Say less messy, because with the PDF files, a lot of issues were with the things that some were completely corrupted, or as humans are doing these certificates, there are typos everywhere. So even in the names of certificates, which is then making harder to match stuff. And you can always do some heuristics and compute the Levenshtein distance between two strings, but then you are slowly introducing your own errors into the process. And with such a number of items, it's hard to figure out whether you broke something or you are now having a large number of nonsense parts. So we wanted and tried to keep the heuristics as little as possible and to have them documented, because otherwise this can quickly lead to incorrect results. We do have additional question. These programs, especially in the US, are compliance driven. And while both programs have their problems, in my experience, more often than not, the evaluation process results in the remediation of a potential vulnerability. This is data that is not visible. They are expensive and perfect programs, but I believe the industry would be worse off without them. Yeah, this is comment from Gerrit that it's not perfect, it's expensive. Basically, what I'm looking at is there is expensive program which is leading to some data that are publicly available, and maybe the expense of the certification will not be increased that much, likely very little, by making this data more suitable for particular tasks that can lead for improvement in security, especially anticipating the vulnerabilities and making it easy for people to realize I'm impacted, or these are the devices I need to keep an eye on. And I will get automatic maybe notification that something bad happened. So thank you, Gerrit, for this comment.
All right. So there seem to be no further questions at the moment. So I'm just gonna direct your attention once more at the survey that Peter asked you to fill out. It is pinned in the chat. So if you missed it, or if you haven't considered it already, please do. I'm sure it will help Peter a lot. Also, I'm sure Peter will welcome questions even later. So perhaps if you're watching this on YouTube, I'm sure using the links in the presentation, you will be able to find Peter's contact, and he will be glad for any feedback. With that, I would like to thank Peter for finding the time to present for us today. I would like to thank you all for showing up and for listening and for posing great questions. And I guess we'll see you all next month with the next talk.
Thank you very much for invitation. And what I like to highlight is that we are no experts in the certification process as such. We are really missing this experience, and you can help us. We had very narrow view as the security researchers, plus we extracted something from the data, but we are really looking for cooperation with people that are day by day doing the certification work, because this can help us a lot. Thank you for that.
Thank you once again, and a nice day to everybody.